Newton's laws of motion. What is the first law? The first law states that an object in motion stays in motion and an object at rest stays at rest unless acted upon by an unbalanced force. The first law also states that an object will remain in a straight line and have a constant speed until acted upon by that unbalanced force. An object's ability to resist change in a state of motion is called inertia. Net force is the measure of the external forces on an object. If they cancel out, there's no net force on the object. In this diagram, you can see two trucks. These arrows with their length, depict the magnitude of the force, and the direction of the arrows depict the direction of the force. In this top diagram, you can see the arrows are both going to the right, one longer than the other. The N stands for Newton. It has one force is 60 newtons and another force, a different type, has 30 newtons. Total, this truck is moving 90 newtons to the right. In the second diagram, there's one arrow going to the right, 30 newtons, and a smaller arrow going to the left, 10 newtons. It's likely friction. In total, the 30 newtons is stronger than 10 newtons, so it is going 10 newtons to the right. You can solve it by subtracting, and the 90 newtons and the 20 newtons are both the net force of these trucks. In everyday life, an example of the first law is a soccer ball that remains at rest until it's kicked. The kick is the unbalanced force acting on the ball, causing it to move. It stays in motion until either friction slows it down or it hits the net or another player's foot. Those are both examples of unbalanced forces that can either set the ball into motion or stop it. What is the second law? The second law states that the acceleration of an object is determined by its mass and the amount of force applied to the object. Acceleration is the rate of change of velocity per unit of time. The unit of time could be days, seconds, weeks, years, etc. In this diagram, you can see it takes more force to push something much more massive. The equation is A equals F times m, meaning acceleration is force times the mass of an object. In everyday life, this can be seen with pushing a shopping cart. If you have a less massive cart with little in it, it takes little force to push it and it doesn't accelerate that much. But when you're walking with a full cart that has many more massive objects in it, it takes a lot more force to push it, and therefore there's more acceleration. What is the third law? The third law states that whenever two objects interact, they apply forces equal in magnitude and opposite in direction on one another. In this diagram, the force of the finger on a wall is equal and opposite to the force of the wall on finger. If you've ever been on a skateboard or a paddleboard and you step on the edge and push, the object slides away quickly and you stumble forward. That is the third law. The force you're pushing on the edge is returned as it shoots away, and you're receiving its force as well. How do all the Newton's laws work together to make an object move? In this example, an object, a book, is lying on a table and it stays at rest. Only once it's acted upon by an unbalanced force does it move. That is referencing the first law. The unbalanced force is my hand pushing the book off the table. The acceleration towards the ground of the book depends on its mass and the force with which I pushed it. As it lands on the floor, the ground pushes back with the same force as the book. All the external forces are equal, so the net force is 0. Here is a review of Newton's laws. An object at rest stays at rest, or an object in motion stays in motion until an unbalanced force is acted upon it. The force needed and the mass of an object is the acceleration. And there will always be an equal and opposite reaction